In this example, we're comparing the force of the magnetic field and the force of gravity. So if I think about what I want to have happen is that the force of the magnetic field is greater than the force of gravity. So I want the force of the magnetic field is greater than the force of gravity. So that means that I'm talking about the y direction, right? This is going to be y, positive y. So my force of the magnetic field, let's draw a picture of our case. So we've got, this is the ground, and I have a wire. And so the wire is going into and out of the page, and I'm looking at the, let's say the current is flowing through the wire and it's flowing into the page. So if I'm thinking about how the force goes, if my fingers are pointing into the page, in order for my force to be up, for my thumb to be up, the magnetic field has to point to the left. So this is my magnetic field, B here. This is B. Right, and so try it. If my fingers are pointing into the page and my B field is to the left, then my thumb is going to represent the force, and so that's going to be the force up. And so this would be my arrangement. And now let's figure out the numbers. My force of the magnetic field is equal to L over C, where L is the length of the wire, C is the speed of light, and then I is the current crossed with B bar. And that represents the magnetic field in newtons per coulomb. And so that's going to be greater than m, the mass of the wire, times g. Now, one of the things they gave us was they said that that they gave us a mass per meter. So that's what we're going to use here. We're going to say that the length is 1 meter, and for the mass, we're going to use the mass of 1 meter. So what I want to solve for here, I have L over C times I, and now to do this cross product, I do I times B bar, so this would be sine theta. Right, so that's going to be the scalar of I cross B, and that's going to be greater than mg. Now I'm trying to get my I alone, so I can, and also if I look at this, my B bar and the angle between I and B bar, for this example, I is into the page and B bar is to the left, so therefore my angle here is 90. So if the angle is 90, then this goes to 1. So I have L over C, I, B bar is greater than mg. If I want to get I alone, I have to multiply C by both sides, so I have I is greater than, and now I bring the C up, times mg, over, and now I have to divide both sides by L and B bar. So L and B bar. And so if I plug in these numbers, my I is going to be greater than 3 times 10 to the 8th meters per second. That's the speed of the speed of light, or the speed of the electrons moving through that wire. The mass is equal to 10 grams for 1 meter, so 10 grams, we need to convert that to kilograms. So 10 grams, oops. So 10 grams is 0.010 kilograms, and then G is 9.8 meters per second squared. And now divided by L is 1 meter, and B bar is 30 times 10 to the 6th newtons per coulomb. So when I'm going to go up here just so I don't have to go off the page. So my I ends up, when I multiply that out, I get 0.98 amps. So if I look at my numbers here, I have a meter here on the top. So I'm going to be able to cancel out a meter here and a meter here. I have a kilogram meter per second squared here. So that tells me I've got the kilogram meter per second squared. That cancels with my newtons here. And so what I end up with is with a coulomb in the denominator on the denominator and a second. So that gives me coulombs per second. So I get coulombs per second, and that is equal to amps. So the units make sense.